Hello everyone, welcome to another video from Advanced Math Tutors. Today I wanted to bring you a series on Calculus 2. Calculus 2 can be a difficult topic because there are lots of difficult concepts. And the first one you encounter is the fundamental theorem of calculus, which states that the derivative of the integral is equal to the function. But I always found this confusing. How can the derivative, which is slope, undo the integral, which is area? And so today I wanted to bring you a more intuitive way of thinking about this. So let's say we have a function, a little f of x. Here it is. We know that it's smooth and continuous, and we know its area function, capital F of x, but we don't know anything else about little f of x. We don't have a formula, we don't have a function, all we know is its integral. And we remember how this integral works from calculus 1. If we have a point x, then capital F of x would be all of this area here. All the area between the x-axis and the function in between the points x and the origin. And so now we ask a question. Using only capital F of x, can we find little f of x? And so what we're going to do is we're going to make an approximation and then see if we can make this approximation better. So here's the function. Let's take 2 points. Here's x, and here's x plus delta x. And so the distance between these 2 points is delta x. And now let's consider the quantity capital F of x plus delta x, and we subtract away capital F of x. And if we think about what this quantity is, capital F of x plus delta x would be all of this green area. And then we're going to subtract away capital F of x, which is all of this blue area. And so what we're left with is only the green area, all of this area here. And if you look closely at what shape this area makes, you can see it looks almost like a rectangle. In this case, it looks a little bit more like a trapezoid, but let's just use a rectangle to approximate this area. Which is easy because we know the area of a rectangle. That's just area is equal to base times height. And now we know what area is. We just found it. It's this. So the area goes in there. Now the base would be the base of this rectangle, and that would be the distance between those 2 points, which is delta x. So delta x goes in for the base. And now the height is going to be this height here. And it's going to be this point here. And that's little f of x. So h we can sub in little f of x. Now it's just an approximation for f of x because this height is not exactly f of x. But we're just going to approximate f of x. So if we rearrange this equation and solve for h, here we have h is equal to area over base. And the area was equal to that capital F of x plus delta x, subtract away capital F of x. And then the base was delta x. Now let's see if we can make this approximation a little better. So here's our function again. Now let's make x and delta x a little bit closer together. So effectively we've made delta x a little bit smaller. Now when we take the area quantity, that capital F of x plus delta x minus f of x, we get all of this area minus all of this area. And if you see, this new area is a little bit closer to that of a rectangle than it was when delta x was a little bigger. And so the error between the area of this shape and the area of a rectangle with the same height, it shrinks as we shrink delta x. So let's bring in calculus. Let's take a limit as delta x approaches 0 of this entire quantity, capital F of x plus delta x, subtract away f of x, and now divide by delta x. And we can say that if we take delta x equal to 0, then this would be equal to little f of x. But if you look closely at what this quantity is, this is the limit definition of the derivative. And so we can rewrite this entire thing as the derivative of capital F with respect to x is equal to little f of x. But this is exactly what the fundamental theorem of calculus says. It says the derivative of the integral is equal to the function. And so we've proved it in a non-rigorous way, and I hope this gave you a little bit better intuition and understanding of the fundamental theorem of calculus. Now, in the next video, I'm going to show you some example problems and problems that you will likely see on your first quiz or test.